Right, so great that you come back and join us. In this video session, we're going to learn about how to use this really powerful, almost magical feature that Pandas offers, which is basically a smart search, right? And we can call it smart search, we can call it intelligent extraction, we can also call it content-based filtering. And what this does is to have a very compact yet very clear way of picking out only those cells, right, where the content matches certain behavior or expression or mathematical properties that we want. By and large, we can always use a loop, right? So for next, for all rows, for each column, scan and pick out the value and then check whether that value is what we want. And that is typically how things are done in various programming languages like C, C++. But that is, again, making the for statement the primary focus, when in fact our goal is basically to say, can you just scan through the data? Data is our first priority. So scan the data and pick out those that are so-called important or make sense to us, that we have interest in, right? So the content-based extraction, content-based filtering of those that we don't want. So how can we do that in Pandas? And that's what we are after. So join me now to the classroom. And this is our classroom, right? And I've done up these colorful indicators to make the entire very fast, rapid operations done by Pandas more visible so that we understand more. Now, going back a little bit in our previous videos, we've gone through how we may use a mask data frame. That means a data frame that is having the same shape, number of rows, columns, same as the content data frame. So we have a data frame that has numbers and data, and another similarly sized data frame that only has true and false. True, false, whatever, right? So arbitrarily. And then we are able to then say df square bracket, df mask, and to extract out those cells that are true. We've seen that in the previous video. And here, we are basically using that. So we are trying to create a mask of trues and false. But instead of manually taking off true, false by hand, we're basically going to quickly create such a data frame by expressions. So for example, we have a data frame here. Okay, so df6, I think that's what we call it here. So we would like to extract the column B, and that's easy, just dfb. But suppose we want to take out all the rows in df6, all right, all the rows in df6 where df6's B column has values that are 7 and larger. Okay, now it's getting a little bit more complicated, but then also not that complicated because we are able to describe the content. 7 or larger, that's all. So what we do manually is that we scan through this B column and only take 7 and 9, right? And because the entire row is what we want, whenever B's cell contains value that is 7 or larger, we would extract rows 1 and 6 for all the ABCD columns. So our result is a data frame, because it's not a series, it's a data frame that would have ABCD and rows 1, 6. The labels are 1 and 6. So the way to do this is this. We can create a series mask, right? Just like we can create the data frame mask, we can create a series mask by extracting df6.b like this. So we can extract out df6.b, all right, and then say greater equal to 7. Now this expression is valid. What it does is, for each element in the series, remember we extract the column, so it's a series. For each element in the series, if it's greater or equal to 7, if it satisfies that, it will be true, and otherwise false. So we'll have, as a result of this bracket here, this series, which is the same shape, same dimension as df6.b, 7 rows and 1 column. And more importantly, the numbers have been kind of transformed or mapped into either true or false. Okay, so 3 is false, 7 is true because it's 7 or larger, and so on. So end up we'll have this mask, right, which can be used as a selector like this. So we put it back into df6 selector. All right, we put it back into df6 selector, and this mask, which has the shape of 7 rows and 1 column, automatically tells the selector that we're going to select by rows rather than by columns, because df6 square bracket quotation mark b will select column instead. So here we're going to select all the rows that have true in them, and end up we'll get df6 underscore 1, which will give us this. Okay, so we'll end up getting this, and the rest will be other values and so on. If we only want 7 and 9, this column, we could have then replaced it with df6.b square bracket df6.b greater or equal to 7. Then it would be a series, a very short series. But if we want all the all the columns in each row of 1 and 6, then just do it this way. The base content is df6. The selector is based on the content of b column. So it's very versatile, very flexible. Combination is endless, right? But of course, we don't do it purposely. We do it because there is a need to analyze in that fashion. So we will do it that way. Now, we sometimes are not interested in the content. We're just interested in which rows, right? Just tell me which rows contain such behavior where the column B has value 7 and larger. We're just interested in getting 1 and 6. We're not interested in the contents themselves. All right. So in such a case, we will still follow the same thing, except our base is not except that what we do is that we will first extract out the df6 dot index, okay, and subject that series to the selector series, and that's fine. We can do that. We can first extract the big index and then select it using the selector mask series. So that's one way. Another way is, of course, probably some of you are thinking, but wait, we already have this data frame. We could also just take out the dot index of this data frame, right? And that would be it. And that's true. So we can also do the same df6 square bracket df6 dot b greater equal to 7, and then extract out the resulting dot index. Also fine. So just want you to know that some of us think like this, straight away we light up our light bulb and say, oh, why don't we just do this? The base content is just because we are not interested in the data, and then we use the selector mask. Some of us, having seen this diagram, will say, hey, look, it's simple. Just, ignore the rest and take out the index from this df6 underscore 1. And that means just append dot index onto this expression. Both ways are legit. Both are absolutely, healthy thinking. And both ways ought to be feasible, right? Ought to be able to be carried out in pandas. And that's exactly what pandas allows. So no matter how we divide ourselves into thinking, going differently to get the same short series having 1 and 6, that means we now know, all right, the rows having 1 and 6 are to be handled separately because that's what we're interested in doing. Then in that case, you can just implement it the way that you think is right, and that's fine. Okay, so why do we need this short index series? Because sometimes we might say those who are seniors will be given priority. Okay, now of course, this is probably not age, but let's say 7 means 70 years old. Okay, so we might want to say extract those people's records, where the records are the rows. Extract those records whose age are 70-year-olds and above. So then we have identified, 7 and 9, but we're not going to process anything about the age. So, for example, we might be giving seniors priority in taking COVID-19 vaccination shots, right? For example. Now, so that's got nothing to do with the actual precise age. Like if you're 70, you're given the least priority amongst the prioritized people. But if you're 90 years old, you're given the first priority. We're not going to do that, right? So nothing to do with the actual age value. But rather, we might want to print out letters to mail to these people, and so we might need their name, their corresponding address in column C, postal code in column D, and so on. So then we will first need to extract which rows are those that we need to process, and so this is where we will get for R in this df6 underscore ind1 index 1, extract out the row and then process the name, address, and postal code. Right? So it can be very powerful, and just with a single liner like that, we're done.